This video was originally presented as part of a tutorial on ways to approach efficient modeling at the 2016 No Magic World Symposium. Thank you to No Magic for granting permission for a wide public distribution of this content. And I encourage you to consider attending a future No Magic World Symposium if you have interest in their products. There are a number of speakers that are featured, invited, and present, as well as the No Magic staff. And it's a great way to learn about No Magic's products and help advance the state-of-the-art of model-based systems engineering. So we'll go ahead and show how we can use inheritance to very nicely inherit traces and requirements and properties. So we'll focus on safety for a moment. So I found it useful to use use cases with a functional hazard stereotype applied to capture functional hazard information. And so I've just applied that stereotype to these two use cases, and we'll go ahead, and this would be as if your safety expert said, you know, bad thing 1 happens under these conditions, bad thing 2 happens under those. We would document those and trace them. We'll go ahead and create a smart package that will find all the use cases that have functional hazard applied. So here is a functional hazard smart package. We'll go to our query, and we'll do a find and find all the use cases. So I'm typing use there, and it jumps to it that happen to have the functional hazard stereotype applied. And I did not choose to make this one invisible because if I did have a use case diagram with these, I'd want to be able to see them. Let's go ahead and build a dependency matrix that will let us find or relate the functional hazards to our functions. So we'll go ahead and create a dependency matrix here. It's the functional hazard trace matrix. We'll make operations our rows, since those are how we're modeling functions. And our row scope will be the functional blocks. And our column will be use cases. And our column scope will be functional hazards. And our dependency criteria will be trace. I found that to be a pretty useful way to relate these. And so we now have a very nice matrix here that we can use to create these relationships. And we can now say that, you know, function 1 and function 2 and function 5 and function 9 all trace to these functional hazards. So again, it's a very rapid way to create those relationships. So we want to show how those inherit. Well, we can now go to our operations table here, which lists all of our functions. Now and create a custom column here to show the functional hazards related to this function. So we'll create a custom column. We'll call this related functional hazards. And that's a MetaChain navigation. That means we're basically hopping between the connectors in our model, between the nodes. So we'll go from operation to relative relationship of source. That happens to be a trace, so we only follow the traces. And we want the traces target. And now we have those functional hazards, and we could do the very same thing and display their documentation. So let's go ahead and do that. Let's say we wanted to see what the information was related to that hazard. We would just come with a custom column, related hazard description, and we'll do a MetaChain for that as well. So direct relationship source, we'll say that that's a trace. It's a target. We know they're all use cases, so we can specify that here. And then we just want its documentation, or actually I think it's called owned comment, and that would give us any text that was there. And so if I come back here to functional hazard 1 and put that in, it's now appearing everywhere that function 1 is. So again, you can build some very complicated generic tables here that you then can export to Excel, and it works really well. So now anything that has function 1, we could definitely trace this functional hazard to, and it will show up, which is really a nice feature. So we'll show that as we move forward.